Alright, so let's say you're given this diagram of a sled under constant uniform circular motion traveling around this circle. And the question says, sled of mass 5 kilograms is given a push on a frictionless sheet of ice attached to a string of length 5 centimeters that causes it to undergo uniform circular motion. If it makes 5 cycles in 1 minute, what is the force felt by the object? To start, we can identify our givens. So it says that the mass is equal to 5 kilograms, and it says that the string is 5 centimeters, so this is going to be our radius value for the circle. And then it also gives us that he does 5 cycles in 1 minute. That's going to be related to the period, so we can write all this down for our givens. And then we should identify what we are solving for. The question wants the force, which will be given by Newton's second law, which is the summation of force equal to mass times acceleration. In uniform circular motion, the summation of forces is going to be in the same direction as the acceleration. Note the radial acceleration is given by this equation here for circular motion. We convert our Newton's law equation to circular motion. A is just going to go to a rad, and we get this here. If we look at our diagram, we can note that we only have one force acting on the object, so we can drop the summation. We can just call it force, and we get this here. But we don't have a rad, and if we remember from our last video, we derived this a rad equation here. This is going to be useful for solving, so we can plug this in instead. And we can note that the directions of the force is going to always be pointing towards the center. Plug in our knowns. We just drop the direction for now and add it back later just for simplicity. Look at our equation so far. We can note that we still don't have t. T is the period, and it's equal to the time it takes for one cycle. Given in the question, we have 5 cycles in 1 minute, so we can convert that to 5 cycles in 60 seconds. Period is going to be equal to time divided by the number of cycles. So if we plug in our knowns here, our time is 60 seconds and the number of cycles is 5. So we get this for the final answer for the period. This is going to be the time it takes for one cycle, and this makes sense because if he does one cycle in 12 seconds, then if we multiply the 12 seconds by 5, because we're doing 5 cycles, we'll get 60 seconds, which is the time for 5 cycles. Now we can apply this to our situation. So if we plug in 60 seconds for the period and our other knowns values, we get this, and then we can just compute the amplitudes into units, and then we get this for the final answer. This is going to be the constant force on the sled while it's traveling under constant uniform circular motion. So we have our sled here, and so at this point, the force is going to be pointing to the center at 16.5 newtons. And then at a later point around the circle, it's also going to be pointing towards the middle with the same force. So the important thing to know is the force will be constantly pointing towards the center, and this makes sense because if it wasn't, then the object would stop traveling under uniform circular motion and be diverted into a different direction.